Hi everybody, this is Nafish. Today we are going to learn two basic things in Python. So one is what is tuple and what is list. So what are the differences between tuple and list? We hear these terms a lot. So I'm going to show you some examples on that and what is deep copy. Okay. So these are the two items we are going to cover in this lesson. Okay, so let's get started. So let me write a list. Okay. Let's say uh, number is equals to 1, 2, 3, 4. This is how we can define a list. So basically a list, we have a bracket, and inside the bracket we can assign some numbers, letters, strings. And a tuple, let's say tuple is we have to have round brackets, okay, when we're going to define a tuple. So 1, 2, 3, 4. Okay. So one thing is like list, we can change the list. Okay. So basically we can assign a new number in this inside the list. But tuple, it's kind of not changeable. So it's immutable. Okay. List and list are mutable. So we can change it. So let me show you what do I mean by list can be mutable and tuple cannot be mutable. So let's say I have number, right? So this is a list because we have brackets, right? So let's say the first element of this list is 1, right? I can see 1. So let me assign this first element rather than 1. Let's say we want to have it 10. Okay. So let's do the assignment and let's look into the list. So this list variable, you see, this list variable which is we are calling number is now 10, 2, 3, 4. It's not the one we had before. Okay. So we can see like we can change the list. Okay. How about the tuple? So we have defined the tuple in this variable, right? So number underscore tuple, right? So this is the tuple. Let's see the first element of this tuple. So we can just easily access that. 1 is the first element, right? Now, what happens if we want to change this? Let's say we want to replace it by 20. Okay. And you see, it's throwing an error. So basically, once we define the tuple, we cannot change it. So it's not mutable. And list, we can always change it, right? So here you can see like we're changing the list. Okay. So these are the two differences. Now, what can be the use case? Okay. Let me show you one use case. Let's say I am calling, I am defining a data frame. Okay, so df is the data frame, and we are calling it a list. But inside the list, we can have a tuple. Let's say my name, and then with my age, and then let's say my occupation. Okay, now we have another person. Let's say, and the name of the person is, let's say, Ash, and age is 56, and he's an engineer. Okay, so this is our so this is, you can see this is one tuple, this is another tuple, and this is inside a list, and we are assigning that to a variable called df. Let's run it. Now if you want to see df, okay, you can see it's kind of, if we write um, some information inside a tuple, it's kind of easy to interpret. You can see like this is one person, this is another person, and these are some of the attributes of that person. Okay. Now, how about we want to access the first element of this list? So let's say first element is 0, and you can see it's giving us the entire tuple. Okay, first element, this is the first element, and that's a tuple right here. Now, what about if you want to change it? So let's try to change it. Okay, and I bet we can change it because this is a list, right? So let's say let's have something else rather than these parameters. So let's say fish, then 36, and is the farmer. Okay, now you assign this, and now let's see our data frame. And you can see we can replace the values because this is A list always starts with a bracket, right? Remember? So we can't change it. Now, how about let's us get into the tuple. Okay. So first element, if you want to see first element of this data frame, so this is what it's showing, right? How about we want to access this first element of this first tuple? So let's say 0. Okay. Run it. It's giving you fish. Okay. Now, can you change this? I don't think so, because this is nothing but a tuple, right? This guy. So let's say you want to assign it to something else and it's going to throw up an error. So let's say you want to say monkey and try to assign it, and you see it's kind of not changeable, it's immutable. Okay, so this is kind of the difference between a list and a tuple, and a small example how we can use it. Tuples are kind of memory efficient. I can also show you that. So let's say import this, and then we can do size of let's say number. Okay, this is our first one, right? Number, which was a list. So number, some error showing. I think it's going to be sys get size of, okay, 88, right? 88 bytes. It's taking 88 bytes. Now we also have defined a tuple right here, just below the list we had at the beginning. So now do the same thing and see what's the memory consumption of that tuple. Okay, and it's going to be less than a list. I'm going to show you that. You see, it's 72 bytes. So it's a little bit memory efficient, I would say, tuples. Okay, and they were actually kind of representing the same numbers: 1 2 3 4, 1 2 3 4. The list and the tuple. But you see, this is consuming this much memory. This is this much. But list, there are much more operations you can do on the list. So this was one segment. So now we are going to go over shallow copy and deep copy. So what are the differences between shallow copy and deep copy? So for that we have to create a data frame. So let's import pandas as pd, and let's have a variable called df. Inside df we have pd dot data frame, and we are going to create a dictionary. So let's say we have a key a which got values of 1 2 3 and 4. Then we have another key that is b, and that got values of, let's say, 10 20 30 and 40. Okay, so we have our data frame. Okay, df. Now we are going to demonstrate what are the differences. So df is right here. You can see we have two columns, a and b, and these got some values. Okay, now let's do a shallow copy. Shallow copy is equals to df dot copy, and here we have to write down deep equals to false. Okay, this is the way we can do a shallow copy. And let's do the same thing, and here we are going to write down the variable name deep copy, and here deep is going to be true. So what we are doing, we are copying the same data frame and assigning it to two different variables. One is shallow copy, one is deep copy, and with different parameters, like deep is false here, deep is true here, right? So let's run these two cells. Okay, so now let's see the values, and we have the same values because we haven't done anything, right, to our original df, right? So this is shallow and this is deep. Okay, so let's say visualize deep copy, same thing. Okay, now let's say we are going to make some changes to our original data frame. So okay, so let's see our data frame df, and our key is a. So, and let's see, let's get our first value, which is 1. So 0 going to give you 1. Now let's assign a number, different number. Okay, so let's say we're going to assign 100 here. Okay, and now let's visualize our data frame df. You see, df is changed right now. So we had df1 here in this position. Now we have 100. Now what happened to our other two variables? So we had a shallow, right? We had a shallow copy, and let's see what is that. So you see the shallow copy also got changed because this is directly linked to this df. Whenever we are going to change these numbers in the data frame, the shallow copy variable is also going to change. But if we want to see the deep copy, there will be no change. Okay, so this is not kind of, once you use the deep copy, this is not anymore dependent on df. Okay, but for the shallow copy, it's always going to be dependent on the df. Okay, so this is kind of the primary difference, I would say.